In modern radio equipment, a rotary encoder is the digital successor to the old-fashioned tuning capacitor. While it looks like a standard volume knob, it functions as an electromechanical device that converts the rotational position or motion of a shaft into digital signals. In the context of amateur radio, it is most commonly used as the main tuning knob for the variable frequency oscillator or VFO. Unlike a volume control knob, that is a potentiometer, which has a start and an end point, a rotary encoder can spin infinitely in either direction. Frequency tuning. As you rotate the knob, it sends pulses to the radio's microprocessor. The processor counts these pulses to increase or decrease the frequency. Menu navigation. Many encoders include a push button feature. You can press the shaft inward like a button to select menu items or change the tuning step. Example, jumping from 10 Hz step to 1 kHz steps. Precision. Optical encoders provide very high resolution, allowing for smooth analog-like feel tuning even though the underlying system is entirely digital. The mechanism is quadrature encoding. Most radio encoders use incremental encoding with two output signals, usually called channel A and channel B. When the shaft turns, these two channels produce square wave signals that are 90 degrees out of phase with each other. This is known as quadrature output. By sensing which channel clicks high first, the radio's computer knows whether you are tuning up or down the band. Rotary encoder versus potentiometer. It is easy to confuse the two, but they serve very different purposes. Rotation. For rotary encoder, it is infinite, 360 degrees over and over. Potentiometer, it is limited, usually around 270 degrees. Output of rotary encoder is digital pulses, zeros and ones, while that of potentiometer is analog voltage due to the variable resistance. Primary use of rotary encoder is for frequency tuning and for digital menus. Potentiometer is used for volume control, squelch and RF gain. Memory. The position is handled by the software in rotary encoder. In potentiometer, the position is physical. Mechanical encoders common in handheld radios and budget DIY kits, as in my ECBTEX and LMR SDR 1.1. They use physical contacts that open and close. They often have detents, noticeable clicks, and are prone to contact bounce, electrical noise as they age. In contrast, optical encoders found in high-end base stations, these use an LED and a light sensor with a slotted disc. They are much more durable, have no contact bounce, and offer very smooth, high precision feel for searching through weak signals on the band.